Lesson 4.4, Factoring Polynomials. It is going to get fairly intense today, requiring a lot of thought. So, factor each polynomial completely. We are going to go through these and just kind of look for things we can factor out. So, for example, 1a, I see that I can factor an x out of all three terms, right? So I can divide an x out of x to the third. I can divide an x out of 4x squared. And I can divide an x out of the negative 5x. Right? So that's going to give me x times x squared minus 4x minus 5. To continue this out, to factor it completely, I need to try to factor this part here. And what I have inside the parentheses is a trinomial, right? What multiplies to negative 5 but adds to negative 4, right? So I have to think that through. Well, that would be negative 5 and 1, right? So this would factor into x times negative 5 times x plus 1, right? So that is the full factored form of example A. For example B, 3y to the 5th minus 48y to the 3rd. Well, I'm going to start off by just looking at these two terms. And I see they both have y's, right? So I know I can factor out some type of y, hopefully to a power. Well, I'm going to factor out the smallest exponent, y to the 3rd. Okay, that's going to leave me with y squared here in the first term, and in the second term, the y portion is going to be factored completely. I see they also both have a coefficient, and I'm going to try to factor out that 3, right? So hopefully I can factor out a 3. I would check on my calculator, is negative 48 divisible by 3? And yes, it would be negative 16. Right, so now I am left with this y to the 3y to the 3rd times y squared minus 16. And I need to see, can I factor this term? So it's kind of like a trinomial in that we could say it has plus 0y in the middle. So I want to see what multiplies to negative 16 but adds to 0, right? Because there's really a plus 0x right there. And that would be negative 4, positive 4, right? So this would leave me with y plus 4 times y minus 4. So that is the full factored form for part B. For part C, I see 5z to the 4th plus 30z to the 3rd plus 45z squared. And just looking at these coefficients, they're all divisible by 5. Okay, looking at the z's, the variable part, they all have a z to a power. So I'm going to factor out this z squared, the smallest exponent from all three terms. So 5z to the 4th divided by 5z squared would be just z squared. And then 30z to the 3rd divided by 5z squared. Well, 30 divided by 5 is 6. And z to the 3rd divided by z squared is z. 45 divided by 5 is 9. And z squared divided by z squared is 1. So I'm just going to have that 9 there. So 5z squared I am done with. However, I need to try to factor this trinomial here and see if I can't factor that out. So something that multiplies to 9 but adds to the 6, right? The 6 from right here. So that would be 3 times 3 gives me the 9, and 3 plus 3 gives me the 6. So 5z squared, that's done. That's just going to get copied down. And then I'm going to have z plus 3 times z plus 3. So on your homework coming up, problems 1, 2, 11, and 12 are like these examples that I did here. Special factoring, we have sum of two cubes and difference of two cubes. What you have to do is pay attention to are two perfect cubes getting added or subtracted, and if so, you can use these formulas to show you how to factor. So let's look at this example. I have x to the third minus 125. Well, x to the third is a perfect cube, right? It's something to the third power. 125 is 5 to the third power. So I have two perfect cubes being subtracted. On the previous slide, we had the difference of two cubes formula that told us if you have, just copying from the previous slide, a to the third times b to the third, that is the same as a minus b times a squared minus a times b plus a times b, sorry, times a squared plus a times b plus b squared. People struggle with this concept of a and b. Well, for our first term in x to the third minus 125, what is getting cubed? Well, x is getting cubed. So my a value for all of these over here is going to be x. Anywhere I see an a, I'm going to put an x, right? X to the third equals x. X squared plus x. And in my original over here, what is getting cubed to make the 125? Well, 5 is getting cubed. So anywhere over here I see a b, I'm going to put a 5. A little awkward there on the x times 5, but we can clean that up at the end. So all I'm worried about is this part right here. So I have x minus 5 times x squared. I'm going to fix the x times 5 and make that 5x plus 25. Okay, I need to check this trinomial here, this part. Can I factor it? Can I go, is there something that multiplies to 25 but adds to 5? Well, 5 times 5 makes 25, but those don't add together to make 5. 1 and 25 don't add together to make 5. So this one is done. And on your homework, you're going to have problem 3 is very similar to this one. Factor by grouping. We have z to the third plus 5z squared minus 4z plus 20. When we factor by grouping, we're going to split it in the middle. Okay? and I am going to factor this part over here. What can I factor out of, I'm going to factor this right here. What can I factor out of negative 4z and negative 20? Well, I can factor out a negative 4, and that leaves me with z plus 5, right? Because if I factor out this 4, right, negative 4, negative 4z divided by z is just z. Negative 20 divided by the negative 4 is positive 5. Over in the other part, right, I need z plus 5 over here as well. Right, I need that z plus 5 to be a factor of these two terms. So what can I divide out? Well, I can divide out a z squared. Right? Z to the third divided by z squared is z. And 5z squared divided by z squared is 5. When I factor by grouping, I am going to take z plus 5 and the other factor is going to be these two, z squared minus 4. The z plus 5 part is done. What I need to do is see, can I factor this any further? So using trinomial factoring, what multiplies to negative 4 but adds to 0, right? There's a plus 0z hiding in this problem. And that would be minus 2 plus 2. So this part here would factor into z minus 2 and z plus 2. On your homework, this is problems 4, 6, 8, and 10. Now, on problem 8, it's a double factor. So you're going to have to factor it twice. So pay attention to that. So number 4, factoring polynomials in quadratic form. I have 16 x to the 4th minus 81. Well, this is really a difference of squares, right? So if I say, oh, both of these are perfect squares. This is a perfect square and this is a perfect square, right? This would be minus 9 squared. The first term is 4x squared squared. So I can rewrite this as 4x squared plus 9 times 4x squared minus 9. What I have to do then is just make sure that I cannot factor these any further. This portion here is done. However, over here, what I can factor this further, right? 2x times 2x gives me the 4x squared. Plus 3 minus 3 is going to give me the negative 9 and is going to make my middle term cancel. Over here in example B, all three of these terms are divisible by 3, and they all are divisible by p squared, right? They all have a p, So I take the smallest exponents. So 3p to the 8th divided by p squared would be p to the 6th. 15p to the 5th divided by 3p squared would be 5p to the 3rd. And 18p squared divided by 3p squared would be plus 6. So now I need to try to work on this p to the 6th plus 5p to the 3rd plus 6. And it kind of is taking on like a trinomial type look because, right, our exponents decrease by 3 from here to here, and then again from there, from the 5p to the 3rd plus 6, we could think of that as 6p to the 0, which would be 1. Looking at factoring this, I want to try to factor out the p to the 6th plus 5p to the 3rd plus 6. Right? I want to try and factor this out. Now the 3p to the squared, 3p squared is going to just come down. But I want to see, can I factor this? And I'm going to try to split up this 5p to the 3rd and see if I can't factor by grouping somehow. Right, so these are going to get copied down. Now, this 5p to the 3rd, I could try 4 and 1, or 2 plus 3. So let's go with 2 plus 3. Let's go plus 3p to the 3rd plus 2p to the 3rd. Right? It's a little bit of kind of poke and hope, guess and check. So 3p squared is going to come down. And I am going to factor these two terms. Well, they're both divisible by 2. So that's all I can factor out there is p to the 3rd plus 3. Right? So over here, I also need that factor of p to the 3rd plus 3. And what I can factor out is a p to the 3rd. Let's put some brackets around here to separate out. So I am going to get 3p squared times the p to the 3rd plus 3 times p to the 3rd plus 2. Right? I combine these two. I group these two to make my my second binomial term. Right? These are tough. Homework. These are 5, 7, and 9. Come get help. Like I said, they're tough. Get help. I'll help you get started on some of these. But make sure to reach out with questions over lesson 4.4.